All right, good morning, good afternoon, good evening, whenever you're watching this video. Today we're talking about absolute value equations and inequalities. Okay. Now, absolute value, you've always heard that absolute value has to be positive. But why does it always have to be positive? Well, let's just suppose I'm plugging in a 7 into this absolute value. Whoops, pin glitch there. A 7 into this absolute value. So we know that the answer to that is going to be 7. So if I plug in a number that is greater than or equal to 0, my answer is always that number. Okay, but where it gets a little bit weird is if I plug in a -7 in that absolute value. A -7 in on that absolute value. What I want to do is I want to take the opposite of that -7 that I plugged in. Now we haven't talked a lot about piecewise functions yet. That's coming, but this is the gist of the idea. Okay, the whole idea, definition of absolute value, is the distance a number is from 0 on the number line. So if I had 7 here and -7 here, we know that this distance is 7. And normally when we go backwards, that we would call that -7. But since we're talking about distances here, both of those distances are 7, which is what this piecewise function is trying to describe. So part of your homework tonight is going to want you to set up some absolute value equations, and then we'll start solving. Okay. Now, whenever we talk about distance on an absolute value equation, the distance is always my answer. It's always what's on the right side of my either equality or, in this case, inequality. Because here, I'm wanting all the values that are within 13 units of the number -4. So that means if I take a number and I subtract 4 from it, I want it to be smaller than 13. Well, since I can go anywhere from, let's see, +17 down to -9, -11 on this, -9, then I want to make sure I put this inside absolute values so that we account for both the positives and the negatives. Let's have this make sense with the ACT. Okay, ACT. This time, the distance I'm willing to go away is 7 right here. So my 7 is going to be outside the absolute value on the opposite side. And I'm wanting to score within so close of 29. Okay. Within 7 points of 29. So it would be set up like this. So for instance, suppose someone makes a 25 on the ACT and they want to know whether or not they did better than average. What they can do is they can plug in a 25 right here for this x. Well, 25 minus 29 is -4. If I take the absolute value of -4, that's just 4. 4 is less than 7. So from what this problem says, yes, they did do better than average on the ACT test. Let's talk about actually solving these equations. I'm going to switch back to equations and we'll do inequalities at the end. The very first step is the most important, getting that absolute value on a side by itself. Out of all the times I've taught this lesson over the years, that's the #1 mistake, is people forget to do this first step. They go straight into step number 3 and try to work it to the end. And so they never even get it set up right. Step number 2 here, it says see if there's even a solution. So suppose that I just get something simple like the absolute value of x inside my absolute value sign. And it says that it's equal to -7. Well, that doesn't make a lot of sense. From what we just found out, if I take the absolute value of x, it has to be something positive, not negative. So if I get it down to something is equal to a negative number, stop. I get to stop right there, not go any further, and I just write no solution. I'm done with the problem. Okay, the rest of the problem probably won't make much sense. You're not going to see a lot like that. You might see a couple, but otherwise, if I do get something like say it's a +7, that is going to have a solution. What I want to do is I want to get rid of the absolute value signs and set it equal to the positive answer and set it equal to the negative answer. I will then have 2 equations to solve. And then step 5, I can go back and check my answer. So let's try this first one up here. Remember, step 1 said get the absolute value by itself. Well, this first equation, I've already got it by itself. And it doesn't equal a -7, so I can go forth and go ahead and start working my way towards a solution. So what I do first is I just get rid of the absolute value and write down exactly what I see. Secondly, I want to get rid of the absolute value, and I set it equal to -7. That kind of takes into account whether it's going on the right side or the left side of the number. Subtract 3 from both sides, and we have our answer. These will have 2 answers. 4. Let's subtract 3 from both sides. I get x equals -10. And if I plug either 4 or -10 back into my original equation, I see that it does work. Okay, these are very easy to check. Now, this middle one right here, it's not solved for the absolute value. We have other stuff going on. So I'm going to need to do the opposite on these in order to get it by itself. It's still not by itself. I need to divide both sides by 3. So that's going to tell me the absolute value of x minus 2 is equal to 5. Now that absolute value is by itself, and it looks a lot simpler, a lot easier to work with. So I get x minus 2 equals 5, just as I see it up above without the absolute value sign. And I get x minus 2 is equal to -5. Just throw a negative on it. Add 2 to both sides. I get x equals 7 and x equals -3. I'm going to let you try this one on the right. Remember to get the absolute value by itself before you start working it. We'll come back and see where you're at. I hope you didn't work it too far, because once I subtract 2 from both sides, I see I've got this absolute value is equal to a negative number, giving me no solution. So watch for that. That's about all the tricks that you'll see on this as far as what we'll do in pre-calc A. Now, with an inequality, we're going to get a little bit more specific, got a few more rules. Notice my step 1 is still to isolate the absolute value. It's still the most important thing that you can do. Okay. Now, instead of equations, we're going to have inequalities. So if we have less than, you're going to hear me not say less than today. Rather, I'm going to say less than, because it's going to give me something called a compound inequality that I'm going to need to slide and in the middle of. Whereas if I have greater or greater than or equal to, then you're going to hear me say greater, not greater, to remind me that I've got to put an or inside my compound inequality. Okay, a lot of the same rules still apply. You can still check your work as you go. Okay, now I've already got a nice one over here on the left. I've already got the absolute value isolated on this left side. So, and I've got a great or problem, great or. So I'm going to put an or in between. So a lot of the same rules still apply. I'm still going to write down the problem like I see it. And I'm still going to write down the problem and then throw in a negative sign. However, when I throw in that negative sign, I need to flip the greater than sign to a less than sign. But then from here, I can still solve both sides. So I'm going to add 1 to both sides. Careful on this. I'm dividing by -3. If you recall, whenever I multiply or divide by a negative on the equality, the sign has to turn around. So I'm going to switch from a greater than to, greater than to a less than. The same thing happens over here whenever I follow the same steps. I'm going to add 1. I'm dividing by a -3, so that's going to turn that alligator around to this side. I do want to still hit on interval notation. Okay, I want us to at least practice this. We get to hear we're doing really well. Now remember, I have or in here. Okay, so my answer needs to be all the numbers that are less than -2. Well, the smallest number I can think of that's less than negative 2 is negative infinity. I can come all the way up to 2. I can't touch 2 because it's not or equal to, so I have the same rule as yesterday. Or, okay, the way I write or is union. And then I can pick back up at 4/3, and I can go all the way to infinity. That one was kind of weird. I'm going to let you tackle this one. Remember some of the same rules that we have going on, and try your best on that interval notation. Pause the video and try to work it. Had to use my eraser a little bit on that one. I forgot to plug in this negative when I was working that out, so make sure you're not making that same mistake. Now I worked it all the way down to interval notation. Hopefully you got x is less than or equal to 5/3 and x is greater than or equal to negative 1. Well, I don't need any infinities when I'm dealing with and problems, okay? I'm wanting something that meets the criteria of being less than 5/3 and greater than negative 1, greater than or equal to. Well, what meets that criteria of being greater than negative 1 and less than 5/3 is every number between negative 1 and 5/3. Okay? Now I have the or equal to, so remember, I want to include the negative 1 and the positive 5/3. So to show that, I put brackets around it.